Okay, this is for 5th grade. This is day 3 of the second packets that went from April 13th through May 1st. And we're working through fractions. This is subtract fractions with unlike denominators. And actually, subtracting fractions with unlike denominators can be some of the more longer problems because they have got a lot of steps. So if you can do some of this work, I mean, you can do just about anything that you're going to see this year. This is, I think, the harder stuff. Okay, so let's take a look at this one here. They're going to want you to look at it on a number line, and so we'll go briefly through this first example. Take a quick look at it. So Felicia lives 1 1/5 miles from school and 9/10 of a mile from the soccer field. Okay, and the question is, how much closer does she live to the field than to the school? How much closer? So 1 1/5 miles from school, 9/10 from the soccer. So how much closer? We're going to compare. So we have to have 1 1/5 whenever we're comparing things minus 9/10. Okay, and let's see if I can clean that up. And so basically we need a common denominator. So we have to have a common denominator. And so the easiest thing to do, and I think we did this on the previous one, or if you were at one of the lessons, is you skip count. Skip count the denominators, because that's like taking a pizza and it's like cutting a pizza. Every time you cut a pizza, you are doubling, tripling, and quadrupling the number of pieces. So you skip count, and then you find the equivalent fraction, just renaming the fractions so that they have the same denominator. That's all that's going on. So first thing we're going to do is we're just going to skip count. We'll skip count. So we have 5, 10, 15, and you can already see where the match is going to be. And then we'll skip count by 10, 20, but we don't even have to really go any further because this first place right here, this is our best denominator that will be the same. It's the least, the smallest common. And when you're with math, you want to keep things simple, so you want the smallest denominator. If we kept on going, we could go up to 20 here, and there's another common denominator that we could use, but we're going to use what's really easy. So then we did that. Now we're just going to make equivalent fractions. So here, let's come under here, and let's make an equivalent fraction. So we have the fraction 1/5, and basically what I'm going to do is make it so that it has, I'm going to rewrite that fraction so it has 10 as the denominator. So what's really going on here is I have a pizza, and I have 5 slices, 2, 3, 4, and I have just one of those slices shaded in. And what I'm going to do is I'm going to say, well, what do I have to do how do I get 10 slices? Well, if I cut it across the middle, I double the number of slices right there. Whoops. Get that again. That's doubling the number of slices if I cut it across. Doubling means times 2. Now I had one big piece, but that's times 2. Now I have 2 smaller pieces. So 1/5 is the same as 2/10. So one big piece is the same as 2 smaller pieces. And that's all we're doing. And I don't have to do anything with 9/10. I'm just drawing the pizza. You don't even have to do that. You can just set that up just like I did with the fractions, and then you're already set to go. You just want 5 times 2 is 10. 1 times 2. So now I can rewrite this. Instead of 1 1/5, now I'm going to say, let me get a different color. Now I am going to say 1 2/10. Aha! Minus 9/10. And so this is what they did. They did this one on a number line. So they came down, and you could do this, but you probably won't on a number line, but it's good to know. Number lines are really important. So there's 0, there's 1 whole. My denominator is 10, and that always tells me how many parts I cut the whole into. So I have 10 parts for my whole. So here's the end of the first part. Okay, and again, you have to think of this as like there's a Twizzler sitting on here, one of those string candies. So right there's the end of the first part. It's 1/10, 2/10, 3/10. And again, what I'm actually counting is I'm counting 1/10, 2/10. I'm counting the space. So make sure you understand that. And then 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10, same as 1. And then they went out 11/10, I'm sorry, 1 and 1/10, and then the very end here, 1 and 2/10. And that's where you start. That's where you start. And then minus 9/10 means you just go backwards, and that's all they did. They went backwards 1, 2, 3, 4, 5, 6, 7, 8. They went back 9/10. That's the minus 9/10. And then they just said, oh, well, where is that? Well, I'll make that a black dot. They said, well, where is that on the number line? Well, that is, if this is 0, that is 1, 2, 3/10 out. So that's one way to do it. Okay, the other way is to think of pizza and then borrow. Let's see if we have enough space here. I think we got enough space down here. So let's come down, and this is probably the way you're going to end up doing it most often. And you'll have your 1 and 2/10 right here minus your 9/10. So what you're going to end up doing is you're going to rewrite this, okay? You'll rewrite this 1 and 2/10, but I'll show you what it looks like in pizza form. So here is 1 whole, and I'll make 2/10 over here, okay? 1, 2, 3, 4. That gives me 5 pieces. 1, 2, 3, 4, 5. Cut that in half. Okay, and now I have, and I'll shade that in. There is my 2. See if that worked. Hold on, there is my 1, 2/10. And we pretend like this whole thing is shaded in, okay? Just like all this is shaded in. 1 whole pizza and 2/10. So if you think of a pizza restaurant. So now you have a restaurant, you have 1 and 2/10 pizza. Somebody comes along and says, give me 9/10. I want 9/10. That's what they're wanting to take. Hopefully they won't. It's not a take. It's a takeout. They're not like robbing you, okay? But if somebody did rob you at gunpoint for 9/10, just give them the pizza. Okay, so we're taking away 9/10. Well, you only have 2. So what do you have to do? Fortunately, you have a whole pizza here. So you just cut this up. 1, 2, 3, 4. Cut it right down the middle there. And guess what? You now have 10/10 of pizza and 2/10 of pizza. Altogether, you have 12/10. You have 12 of these slices. Now you can give away 9, okay? So what happens actually, though, is up here, you're just going to know that. You're just going to know that. So you're going to go, oh, okay, well, I'm just going to borrow. You're basically borrowing. So I'm going to take that 1 whole and cut it into 10/10. So altogether, you'll know you have 12/10. And you can show this a variety of ways. You could just cross that off, you know. You could certainly draw the pizza like we did down here. There'd be nothing wrong with that. No problem. But now you have the same denominator, and you can subtract. Okay, 12/10 minus 9/10. That's 3/10. We can't simplify that anymore, so 3/10 is the final answer. Okay? So you're all set with that one. Hold on a second here. I want to make sure. Sorry, I just want to make sure I'm still recording. I have had multiple times where I'm recording, and then it stops, and I've taught for like 10 minutes and didn't realize it because I can't see the recorder. Okay, let's come on. Oh, so let's just look at this next one here. I'll get rid of that. Again, you can stop, go back, get these notes. Okay, let's get something a little darker here. How would the model and answer in the example change if Felicia lived 7/10 from the soccer field? If she lived 7/10 instead of, how far was she from the soccer field? Oh, 9/10. How would it change? How would the model and the answer in the example change? Well, you would just be subtracting 7/10 instead of 9/10. You would be 1 and, sorry, got to look up here again, 1/5. 1 and 1/5 minus 7/10. Okay, so you would just be, I guess what you would say here is you'd be subtracting 7/10 instead of 9/10. Okay, hold on a second here. Let me pause this. Yeah, I'm sorry. So you would just be subtracting 7/10 instead of 9/10. So you could just say, we know 1 and 1/5 is 1 and 2/10, which equals 12/10. Remember, we already did all this up there. So you would have 12/10 minus 7/10, whoops, equals 5/10. That's all. So you would just say, you would be subtracting, this is okay for me, I mean, as long as you know how to do the, as long as you know how to manipulate the fractions, you would be subtracting 7/10 instead of 9/10. You could have something like that. Okay, let's look at the next one here. Eric says he knows 9/10 is 1/10 less than 10/10. Okay, so actually, or 1 mile. All right, so it looks like Eric is using a benchmark here. This is a really good strategy, actually. So Eric says he knows that 9/10 is basically, it's really close to 1 mile. That's what all that says. Like one more part, and he'd have a whole mile. So he's going to subtract 1 mile, then add it back. Can he use this problem to solve the example problem? Okay, so our example problem was 1 1/5 minus 9/10. And then we changed it to 1 and we found our common denominator, 2/10 minus 9/10. Okay, so what Eric is saying is like, hey, he's really using some good estimation. He says 9/10. Okay, 9/10 is, remember this little wiggly, is about 1 mile. So in his head, he's going to say, I'm going to subtract 1. But since he's going to subtract 1/10, right? If he subtracts 1, if he added 1 more tenth here, right? You'd go to 10/10. If he's going to subtract 1/10 more, he has to add it back at the end. Add back at the end. Okay, so let's go ahead and let's add 9/10 plus 1/10. We have 1 2/10 minus 1, which is a really cool idea because now it's like, oh, that's easy. So 1 2/10 minus 1 is just 2/10. But I did subtract 1/10 more, so now I have to add that back. And 2/10, add back that 1/10 equals 3/10. And that's what we got. Remember, that's what we got originally? That's a it's a great strategy, and it's one that you can use where you add and subtract at the end, or subtract and then add at the end. You know, as long as you go back and correct. We'll say yes, he can. Yes, he can. Yes, he can. And then you can say, I show this in the notes. And then just draw an arrow. So whenever you are, and then maybe a bracket or something like this. Okay, so whenever you're doing some work and you say, well, yes, I can show this. And if you've done the work, just draw the arrow in math. Draw the arrow to there. And then that will help you. The reader will know that's what you're talking about. Okay, so I'm just referencing or showing my work. It's a great way to explain it. You can say, you know, my work clearly shows that you can use this method, and you just make an arrow. Okay, so here we go. Sometimes it is helpful to rewrite mixed numbers that include a fraction greater than 1. Rewrite a mixed number, okay, to include a fraction greater than 1. Use the number line to write the missing numbers. So, for example, we just did that. On that example up there, we had 1 1/5 minus 9/10, and we had to say, well, first of all, remember we changed it to 1 2/10, and then we said, whoa, we can't, you know, one method, now there are several, one of our methods said, well, let's go ahead and rewrite this. Let's cut up this one whole pizza so that we now have 12/10 minus 9/10. That's exactly what we just did, okay? It was one of the methods. Remember, we had a number line, and then we had, you can add a tenth and subtract a tenth. So, hold on, I'm just going to check something really fast here. I'm still recording. Okay, so this is a good strategy. This is our mixed number. This is our fraction greater than 1. We rewrote that to a fraction greater than 1, also called an improper fraction. Okay, and it's very helpful. So let's take a look. I'm going to erase this. So if you can put this in your notes on a piece of paper if you need to, but I just don't have a lot of space. So I'm going to erase this really quickly here so I can work with this extra space. Okay. Grab a color. So 1 and 2, 6. So let's go 1 and 2, 6, right? So you could say to yourself, well, I have one whole pizza, okay, and then I have another pizza with 6 parts. So it's, I could do it like this. Okay, there's my 6 parts, and I have 2 parts, right? All right, and then I have this one whole pizza here. So if I want to rewrite this mixed number, this is the mixed number. It's a mixture. It's a mixture of a whole number and a fraction. So if I want to rewrite that as a fraction greater than 1, like we did last time, then I'm just going to cut my pizza up. So I'm going to cut this one up into 1, 3, 4. Now I've cut that up into 6 parts. 1, 2, 3, 4, 5, 6. So I have my one whole now is 6, 6 plus 2, 6 equals 8, 6. Okay? And that's all you're doing here. That's all you're doing. You can 1 and 2, 6. Okay, so you can also, on the number line, they're showing you these are all from 0 to 1. You can look over here, and there's 6 parts. They cut this up into 1 part, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. So I could literally say, well, I have 1 whole and 2, 6 is the same as 1, 2, 3, 4, 5, 6, 7, 8, 6. Okay? Same thing here. 2 and 2, 6. Okay? And let's do letter B. 2 and 5, 6. And then they want to rewrite it so that it's 1, and they want to take one of the wholes out. So let's look at that one. So what they have here is 2 and 5, 6. And I think a decomposition is a really good way to do it. They want 1 and how many? 6. So we can think of this, as you learn to do like in 3rd grade, is I got 1 whole. Let's take one of those pizzas, and I'll cut that up into 6, 6, and then I still have the pizza with 5, 6. So make sure you understand this. I had 2 wholes. I kept 1 whole pizza because they want 1 whole pizza, right? Over here, they want 1 whole pizza. And then I cut 1 into 6, 6, and 5, 6. Gives me 11, 6. Okay? 1 whole and 11, 6. If I do it on the number line, I can also do the same thing on the number line. And that's pretty neat. I can go to 2 and 5, 6, which is right here. And I can start at 1, right? Because they said I want 1 whole. So now I'm going to jump. And that would be 1 whole and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 1 whole and 11, 6 to jump up there. Okay? All right, let's do the rest of them here. I'm just going to give myself a little space. Okay, hold on. Okay, let's do 2. I just made some space here for myself. 2 and 2, 6 equals 1 and so many 6 here, okay? So we're doing letter C now, on letter C. So again, oh, I made a mistake. Not 2 and 2 halves. 2 and 2, 6, sorry. So again, let's just take this and let's break it up. So we have 1 whole pizza, cut 1 end up into 6 parts. So we got a whole, 6 out of 6, and 2, 6. That gives me 1 whole, that's my 1 whole, and 8, 6. Okay, looking on the number line, if you want to do it on the number line, just as easy to do. Let's go a little darker on the gray. So we have 2 and 2, 6. We want 1. Is 1 and how many 6? So I'm going to start here. I want 1 whole pizza, and I got to jump to this part. So how many 6 to get to there? Well, 1, 2, 3, 4, 5, 6, 7, 8. So 1 whole, big jump, 1 whole, and 8/6. There's another way to show that. Okay, clean this up. Let's do the next one. Okay. This one is 3 and 1/6, and then you can do it however you want. 3 and 1/6. And so let's put one pizza here. We'll put one whole pizza, okay? Equals 1 and how many 6? So let's just decompose it like this. We want one whole pizza. I got 6/6 for my second pizza. My third pizza I'm also going to cut up. And then I still have this one part here, 1/6. So that's one whole, which is, I'm going to show right there. And then 6/6 plus 6/6 is 12/6 plus 1 is 13/6. So that's what this equals. Okay? Again, if I start at one whole, and I'm going to count up to how many 6 to get up here, how many slices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 6. All right, good job, good job. Let's look at this next one. What is 3 and 1/3 minus 1 and 1/2? So we have, let's change color here. Let's do brown. So we have 3 and 1/3 minus 1 and 1/2. So I don't have my denominators are not the same. So I have got to I've got to fix that. I'm trying to get a better angle here on my camera. If I move to the left, it looks like I moved to the right. Okay, so we have 1/3 and we have 1/2. So we need a common denominator. So basically, easiest thing to do, skip count, and then an equivalent fraction. Just write an equivalent fraction. Just rename the fraction. So let's do some work with that. Let's skip count. Let's do skip count by 3. So 3, 6, 9, 12. Skip count by 2, because 2 is my denominator. So in that pizza I have 2 slices. If I drew one line, I cut them, and I have 4. Another line, I have 6. Okay. Another one, 8. And right away, I can cut both of those pizzas so they each have 6 slices. And that's what I'm going to do. I'm going to pick the first one that's in common. So let's do that. So let's do 1/3. And I want to make that equal to 6 slices. So I have to double the number of slices. So 3 times 2 would give me 6 whole slices. And if I cut all of those one time, right, and double it, I'm also doubling this part. Okay? What did I just do? This is what I just said. I've got this pizza, and I've got 1/3. And what I said is I want to make it have 6 parts, so I cut it across like this. So not only do I have 6 parts in my denominator, because now it's 6 parts to make a whole, but that one big piece I turned into 2 smaller pieces. Okay? All right, so this becomes 3 and 2/6. Okay? Now let's do the same thing with 1/2. And I'm going to have to get rid of some of this space here. Okay, so now we have 1/2, and I'm going to make that pizza have 6 slices. I'm going to triple the number. What did I just do? There's my pizza of 1/2. And what am I doing? I'm going to make a pizza with 6 slices. So I'm going to triple the number of parts. Watch. Now my pizza has 1, 2, 3, 4, 5, 6 to make a whole. And I had one big piece, but I tripled it I cut it into 3 smaller pieces, I should say. I cut it into 3 smaller pieces, 3/6. So this is minus 1 and 3/6. Okay, now here's where it gets tricky, because look, you only have 2 6, and let's say this is a customer for your pizza and he wants 3 6. Well, you have some whole pizzas, and this is where this really helps. Let's come back and look at this again. Remember, this is what we just did. Same thing we've been doing. We're going to decompose that. So we're going to decompose that 3 and 2 6. We're going to take one of those pizzas and cut them up. So we have one whole pizza, and then one of them, that third one, we're going to cut up. And then we have 2 6. We already had the 2 6. So we only need to borrow one whole pizza, and we cut that up. That means total whole pizzas now are 2 total parts. 6 plus 6 plus 2 6, we have 8 6. Now we can subtract one whole and 3 6. And that is going to equal 2 whole pizzas minus 1 whole pizza. 8 6 minus 3 6. Solution is 1 and 5 6. Ta-da! Pizza math works every time. All right, let's come down here. Let's take a look at number 5. Number 5 here. Get rid of this stuff right here. Okay. Let's go with this dark gray. Emily's backpack weighs 6 3/8 pounds. He removes, Emil's, not Emily. He removes a book that weighs, he takes out something that weighs 3/4. Then he removes a book that weighs 1/2 pound. Well, I don't remember doing this one. So we are going to do, we have the backpack weighs 6 3/8. We're going to take out a book that weighs 3/4, take out a book that weighs 1/2 pound, and then see how much it weighs. So here's what we've got. We've got 6 3/8. We're going to take out 3/4 of a pound, and then we're going to take out 1/2 of a pound. So we're going to subtract. We're going to subtract two things. We can only subtract one at a time. So we don't have common denominators here, so let's skip count. And then let's write an equivalent fraction. That's all we're doing. So let's do this first one, 8s and 4s. Okay, so skip count by 8. 8, 16, 24. Skip count by 4. 4, 8, 12. And already you can see this is the first one. If I kept going, I could count by 4s and get up to 24. No, actually I could get up to 16 is next, right? But the first one, if you work with the smaller numbers, then it's easier. It's much easier. Okay, so now we did our skip count. Now we got to write an equivalent fraction. So we're going to change 3/4, and we're going to pretend like that's a pizza, and we're going to make that have a denominator of 8. And I won't draw the pizzas this time. We're just going to times both of them by 2, because 4 times 2 gives us 8 slices. And we have to multiply both of them, because you saw in those drawings. Remember, if it's a pizza, you're cutting the whole pizza, including the slices you have, and you're changing the way that pizza looks. Okay. Okay, so now we're going to rewrite this. This becomes 6 3/8, and instead of minus 3/4, now we can say, oh, we're going to take away 6/8, because that's our new equivalent fraction. Now here's where these problems get really complicated. Now you have to borrow again, just like we were talking about earlier. So now we have, this is a 3 right here. So now let's borrow a pizza. So we'll do 5. We'll take one of our pizzas, cut it up, and we still have the one pizza with 3/8. And again, I always think of it as pizza, even though we're talking about pounds. Okay, so altogether we have 5, and I'll draw an arrow like this because we're going to continue over here. We have 5 and 11/8. See the 8/8 plus the 3/8? Now that's going to give us a lot of slices, a lot of parts. Now we can subtract the 6/8, right? Like this. Okay. And 5 and 11/8 minus 6/8 is 5 and 5/8. Does that make sense? Because 11/8 minus 6/8. All right, and now, this is tricky though. Don't forget about the 1/2. Now I have to subtract 1/2. Now this one you might just know. You might just know. Because think about 1/2. Okay, there's a lot of ways to write 1/2. Okay, you can write 2/4, 3/6, right? Because you're saying I have 2 slices, 2 parts, and I want half of the parts. That's 1. Here, 4 parts, I want half of them. That's 2. 6 parts, I want half of them. That's 3. 8 parts, I want half of them for 1/2. That's 4. So this really just can become 4/8. And now we can do it. Now we can do it. 5 holes. I still have 5 holes. And then 5/8 minus 4/8 is 1/8. And this kind of might look kind of funny to you. I'm doing a certain step. I'm doing one step, and then I do another step in each line. And you can do that. So I didn't put, although the cat was in the way, I could have gone over here and I could have put 5 and 1/8 like that. But I can also show it on a separate line, and that's acceptable as long as I put that equal sign there, okay? That's acceptable. So 5 and 1/8. All right, let's see what's next. Oh, that's it. That's it. That's day 3 right there. So we got it. Don't forget to come back and review. You did a great job. You can skip. You can always reference these. And then I'll show the fluency on another time.